That's a good name.
Good afternoon. I think we're going to get started now. I am Sharon Sharella. I'm the Vice President for Amazon Mechanical Turk, and I'm excited to be here today. I think we have a really interesting talk for you. I'll start with a little bit of background. Mechanical Turk is a marketplace for work, and just like all of Amazon Web Services, we give businesses and developers access to on-demand, scalable resources. In the case of Mechanical Turk, it's on-demand, scalable people, or human intelligence. And it's a marketplace. So we have 500,000 workers in 190 countries around the world. And they have different skills, different specialties, different tasks they like to do. I think one of the things that's interesting about the business is that most of what you've probably heard today has really been about technology. And Mechanical Turk is an interesting mix of technology and people. And that's not to say that we don't think technology is moving forward and moving quickly and will solve more and more problems. But there are some problems that technology really just isn't good at solving yet. And that's where Mechanical Turk really comes in. A lot of the customers who use us with a mix of both a technology solution and a human solution, or the Mechanical Turk solution. The use cases for Mechanical Turk are very broad, and in a few minutes, Mike Brown from Comscore is going to come up and talk about how Comscore has been using Mechanical Turk. But just as way of background, I wanted to kind of go over some of the other use cases that we're seeing more broadly. One of the key use cases that we see with Mechanical Turk is user-generated content moderation. So as more and more websites allow you to upload photos or create user profiles or comment on blogs or any number of actions that can be taken by a broad community, this creates really wonderful, unstructured, dirty data. All those photos are completely unstructured. No one knows what's in them. We barely know what they were if they're rotated the right way, and sometimes we know geodata, but we don't know that much about them. So when you go into, let's say, Facebook or LinkedIn or any of those places, you have the option of report this image as bad. Well, what do you think happens when you click that link? That actually creates another data point, which is, okay, someone thinks this image is bad. I still don't know if it's actually bad. I need someone to look at it. And those are the types of user content moderation that we see coming through Mechanical Turk, whether it's look at this LinkedIn profile and tell me if it's a spam profile or an advertising profile, or if it looks like it's a professional person who should be on LinkedIn, or look at a picture that was uploaded to any number of social networks and tell me if it meets my site guidelines, or look at a blog post, or look at a product review. All those things are great use cases for Mechanical Turk. Some of the other ways that Mechanical Turk is used include transcription. I don't know if any of you are walking around exchanging business cards today, but LinkedIn actually has an application called Card Munch, where you can take a photo of a business card and it magically goes up into the ether and you get back all the metadata associated with that business card. Well, that actually goes to Mechanical Turk, and a worker transcribes that information so you don't have to, essentially. And so it comes back down to you. You get the name of the person, their business title, their contact information, and basically it's a cleansing process. The picture is unstructured data. The actual fields associated with a profile of a professional is much more structured data. So these are some of the use cases that we see a lot with Mechanical Turk. And like many of our web services that we've talked about today, Amazon actually is a big customer of Mechanical Turk. In fact, one of the very early use cases for Mechanical Turk was really helping us when we expanded to third-party merchants. So if you remember, many, many years ago, you could only buy things from Amazon on Amazon. And then we opened it up and we said, we're going to let third-party merchants come in and offer their products for sale. And we think it's great for our customers because now they have more variety, and there's some merchants who will carry things that we can't carry or don't carry. So it will really expand the selection, and that's really important to our customers. But in that process, what happened is we got lots and lots of essentially catalogs uploaded from thousands of merchants from around the country. And what we found is that those catalogs were not normalized. They were really dirty. There might be one item in our catalog, that we sold directly. And it might be represented in 50 different ways by other merchants who are selling the exact same item. So the challenge for us was we want to present you with one item, and you can select which merchant you want to buy it from. In order to do that, we need to know, is this item the same? So in the very early days, we started using Mechanical Turk actually to help us understand, are these two items the same? Is this really the exact same, iPhone case? Is this the exact same video game, or is it a different version? Is this Call of Duty 1 or Call of Duty 2? Which one is it? And so really helping us essentially normalize all these databases that were coming to us and dedupe and cleanse our catalog, our database of items. And we have, we have about 500 million items in our product catalog, so it's a pretty big task. But obviously, not all of those have to be looked at by a human. So we definitely use technology. We have algorithms that help us clean that, and then we use humans to help us clean it the rest of the way there. And we continue to marry both those processes together and refine both of them so we get better and better at it. But that was one of the very early use cases that we used Mechanical Turk for. And another one, which is really, we use it for, as do others, is search relevancy. So search companies are always updating and tweaking their algorithms. What better way to assess if you're getting better every time you tweak it than to ask a wide range of average users whether or not the results have gotten better, and then do comparison tests and track that over time. And we do that with our product search, but there's lots of search companies who do it as well with a broad range of searches. So those are just some of the use cases that we see. The one that we're going to go deep on today is actually a use case at Comscore. So I want to introduce Mike Brown, who is the CTO of Comscore, and he's going to talk about how they've been using Mechanical Turk to help really with their big data cleansing and categorization. So please welcome Mike Brown.
Thank you, Sharon.
Okay, thank you. All right.
Well, thank you all for coming. So just out of curiosity, how many people have heard of Comscore? That's great. So Comscore was founded in '99. I like to say I was the first engineer there. We have about 2,000 clients worldwide and about 1,000 plus employees spread throughout the globe. Our headquarters are out in Reston, Virginia, outside Washington, D.C. And we have global coverage, so we're observing what's happening in 220 different countries, both from a panel and from a census perspective. So today, what I'm going to talk about is our use case of how we started using Mechanical Turk. Before we talk about the use case, we're going to talk about what does our client see today. So on the screen here is something that any client who subscribes to our product, AdMetrics Advertiser, can go ahead and find out. So this is competitive intelligence for people that want to understand what's happening in the advertising space. So if I'm Chase, I can go ahead and log in and see what are the ads, what are the creatives, as it's used in the industry, that Citibank is running out there. So for example, if they notice that they're losing market share, or Citibank is gaining some popularity, this is a great tool for them to go in, log in, and see what are those creatives that is driving that lift to the site, or where are they running those ads. So you're trying to find, it's a tool for people to understand not just the metrics, the numbers of what's happening at those individual sites, but what are the creatives? What is the piece that's happening? Now, we see these creatives, and these creatives are happening and being observed through our panel. But it's really a tough classification problem because you'll see something like this ad for Citibank. So we know this is a Citibank ad, but if you look at it, look at the text. There's nothing that says Citibank. There's no logo. There's nothing. We'll talk a little bit further about this in the deck, but we tried a couple different approaches. First we had to get the product going. We did manual classification, and anybody would chip in some extra time. You classify these, et cetera. We tried computer vision, we tried OCR, we tried some really crazy frequency analysis on colors, all kinds of different types of approaches. And this is how we're going to talk about how Mechanical Turk fits into our ecosystem of classifying ads. So one of the things out there is we have a panel. So a foundational data source for our company is we have this panel. There's 2 million people worldwide that have opted in to install this software on their computer to be part of our research efforts. As people are surfing on the web, we're observing everything they're doing and capturing pieces of information about that. So when we see them visit a web page, let's say they go to www.amazon.com, they click on something, there may be an ad that's displayed there. We're going to go ahead and automatically look for anything that looks like an advertising creative. Something that's a shockwave, an image, or anything that has the standard sizes of what are called ads. Create an MD5 hash of that to create a fingerprint of it, and then we'll record it. So we've now gone ahead and you have a basic idea of we have this panel that's observing in real time what's happening on all these machines around the world. So then we start aggregating this data. And we say, okay, for this location, let's say it's the US, these are the creatives that are showing up. So we first start ranking these creatives. Because we'll see over 4 billion ads in a month. And 5 to 10 million unique ads every month show up. So when we see those, we rank these based on the most commonly seen. We take those and we put those into our algorithm to start looking at this. The other thing we do is we needed a solution that would scale out over multiple countries, multiple languages. And that makes it a lot more interesting because you run into different things like Spain versus, Canada versus US or Britain, right? You know, as I think Winston Churchill said, it's 2 countries separated by a common language or something. So that's where it gets really interesting is how do you create a product that can scale out over multiple countries, over multiple languages to classify this information? Because your source is coming from what real people are seeing. So this is not something where we're going off and spidering all these web pages, downloading those pages, looking for all the ads, because you don't get geo-targeted information. You don't get profile-based information. You don't get RTB-based deliveries of what's happening. So you're going to see what real people are seeing from an ads. So the first part is display ads, and that's what you're seeing here. So you'll see some examples. You have a European ad on the top. You have one for Frontline, and I think it's French. An AT&T ad at the bottom, etc. In addition to that, there's a lot of advertising that happens in Facebook. Anybody heard of that company lately? Facebook? So you have display ads, which I talked about, and then now you have the Facebook pages. So when people are visiting, the panelists are visiting those Facebook ads, those Facebook pages, we're seeing what Facebook ads they've been targeted, because Facebook ads are highly targeted. We grab that, we grab the sponsored stories, look at that to start parsing what's happening. So to get at the true information of those ads, we have to extract all of that information, plus some more to get the clues for that to work. So the first process flow is we have a production Hadoop cluster. It's 100 nodes running in-house. And what we do is we take all those captured HTML pages, run those through the Facebook entity stream extraction to get a set of entity partitions. Those partitions then go through our dictionary. So we already have a dictionary that classifies these are what the web pages look like. This is what these things belong to financial services. This belongs to consumer products. This belongs to cars, etc. And we classify it into the Facebook ads or Facebook news and profile. That alone is a fairly decent data problem because every day we have to process 70 gigs of new data. So that's why we have extraction. So extraction takes this data, all in, it's around 2 terabytes compressed, or 6 terabytes compressed, covering about 320 million pages. So we have to run through all those different news feeds that are happening from all those web pages that people are visiting just on Facebook and extract that out. Works out about 3,700 pages a second. And we can get what's happening and gives you now the loaded, the distinct Facebook pages. So the first part is we have ad metrics. So 85 million ads are coming from Facebook. And that is powering the social essentials part of ad metrics. So you get about 351 million news items with about 29 news items per page. It's amazing how many different news items show up on an individual, every Facebook exposure. So now we have these 6 million unique ads. We have already defined in our advertiser space 56,000 companies spread over 100,000 company and brand pairs. So a lot of our clients want to go ahead and say, I want to understand what's happening in automotive. And within automotive, I want to see what Toyota is doing in the 4-door segment with a hybrid, comparing that to what's happening in other cars. So that's what the type of dictionary you have. But how do you take these ads and map it correctly, quickly, and most importantly, inexpensively? Because with 6 million of these coming in all the time, it's not very scalable to hand it out to a couple hundred employees internally to do that, let alone not everybody's, I don't speak French, I don't speak Spanish, I speak German, but that's the challenge you have of taking an ad that looks like phones starting for just under $1 for AT&T. So when you look at this, is that an ad for AT&T? Is it an ad for some kind of a smartphone? That's where it's a very interesting challenge of how do you figure out what that is? And interestingly enough, humans are really good at that. So as I mentioned earlier, we tried some things. We love throwing, a lot like Amazon, a lot of the Amazon engineers, we love throwing really interesting technical solutions at problems. And we first said, when I started off in computers, I originally started off in image processing, did a lot with OCR and barcode processing, and I was like, oh, this is a great OCR problem, we got this, they're small, et cetera. Extract all the text, and people who write these advertising creatives, they're not trying to make it easy for us. There's very rarely a clue. We went down this whole path and basically just came up with the conclusion that OCR gave you really bad data out of that. We then went down a path of taking every shockwave, decompiling the shockwave file, extracting the string table out of it, and found out again that there was just sometimes even stock text that was thrown in there that was confusing things, didn't work. And we said, hold on a second, every one of these ads has a logo in it. Let's build something. So we built this whole thing with OpenCV and did image recognition and a whole lot of CPU power to search for that. But then you ran into these red herrings that John's Ford dealer in Texas was doing a local ad. That wasn't a Ford ad, it was a local dealer ad. So because again, we're seeing the ads that are happening on the real internet. They're happening by lots of different folks. And it's amazing how people have adopted putting ads. Everybody thinks of the major brands. And from a classification problem, when we were looking through this, we found that we were running through different ads and seeing what was happening. We saw ads for like funeral homes. A lot of people have adopted the internet to do advertising. It's quite amazing. So that's how we came about Mechanical Turk. So we said, okay, let's take some automated classification because there are some things that we can do. Sometimes you can look at the click-through URL, you can look at some text and have a decent idea. We can look at panel activity to say, they clicked on this ad, they went through here, we know they landed on a Ford page, that gives us a good idea. But it doesn't give us the whole solution. You're always coming up short on millions of ads every month that you have to understand and get new data about. And that's where Mechanical Turk came in. So Mechanical Turk made it really nice. So in our implementation of Mechanical Turk, what we do is we actually asked at least two people to look at every ad. So it's not like we ask someone to look at the ad, classify it, put it into a category. We do that once, and we do it twice. If they agree, life is good, we move on. If not, we kick it off into ask another person to come into a tiebreaker. So you have automatically a nice QA of someone that you target that towards Mechanical Turk. You can say, okay, I want people in the US, so you get that cultural understanding of what's happening in the US, or in Brazil, you get the Brazilian, because there's a lot of products that are advertised in Brazil and Portuguese that are not advertised elsewhere. Same thing for the US. So that's how we were able to go ahead and we have an auto classifier, and then we have % ads being run through Mechanical Turk. So how does this all work? So we take the classifying we take the ad or the creative, and we have to get the product name. We have to figure out if it's a new product, because people tend to advertise new products, so it always makes it an interesting choice of when do we have to create a new product. You have categories, company names, and the URL. So all these ads go in and get loaded into a queue that we then can control very nicely based on needs of the business. So we can say in the business, we're going to open up a new country. So we're going to have a lot of new ads that will now have to be classified. Or we're going to open up a new product category into our system. So we'll go in and we'll ingest or target a whole bunch of new ads to come into that. We'll turn that on. And from a business perspective, we can say, okay, I have a whole backlog I want to get to build out the baseline. I can easily throw more items, increase the workload, and these thousands of Mechanical Turkers spread out throughout the world can automatically go ahead and start subscribing to work, and we can get through that very nicely and exceedingly cost effectively. So how does this look? So from a product category classification, someone will log into Mechanical Turk, which is a page this is an actual screenshot of how a Turker, I think as everybody calls them. There's a whole new lingo you have to learn when you work with Mechanical Turk. But, I'm sorry? No, Turker. They're called Turkers. The Turkers that aren't so good, we call them turkeys, so when someone logs in, they get a work and they can accept a hit. So you have this choice of choosing whether it's a hit is a new item for a Turker to work on. They can accept it or they can skip it. So they log in, they see the ad, which is MyFox, and then we're going to ask them to put that into a category. So now you can see here, they have this ad, and there's a list of categories down there. They can click through that, choose that category, and put that ad into a specific location. Then we get into product name classification. So now we go ahead and we have this, and we've done the whole typing part where it's automatically, as you type it, it starts filling in the words to help you get to something if they can't see it. Because the goal is you want to have these Turkers be productive, because the Turkers choose which queues they want to work with. So just like we get to know which Turkers are really productive and high quality, the Turkers, it's a marketplace for the Turkers. They get to choose which work they want to work on. So you want to have a good experience for them. You want to have, it's a very interesting dynamic of this whole cycle going on where you're creating work. You want to have it be easy and fast so they can do it because they get paid per unit. So then you can see here of product name classification, product name by Turk. So I mentioned earlier that we had done internal classification, we had hired some contractors to try it, et cetera. And we did a test because our product is data. We sell data about what's happening out there, and we want to make sure we have a high quality, highly reliable product. And when we did our test, we took the same ads, had it done internally, then also put it out to Mechanical Turk, and we did the comparison of how those two pieces looked. And it came out really cool that they were basically equivalent, but at a fraction of the cost. So that's why we don't classify ads ourselves anymore. We You leverage Mechanical Turk with a nice set of data coming in every single day automatically into that queue. You can see here we have some graphs showing you how consistent the flow is. So you have, over time the ad counts, and you have resolution rates, and existing product rates, non-ad rates, and new product rates. So these are different statistics that we keep track every day to understand how things are happening. And we'll see things up and down based on whether the business has defined new categories or we're launching in a new market or something to that effect. And you can see volume. We can throw a lot of work at it. We can keep it out there. And the category resolution rate continues to do very nicely. And that's something we keep an eye on is, are we matching these ads into that resolution rate? Because if you go down and you leverage Mechanical Turk, you need to have some metrics that you keep track of to understand how well the system is working so you can continually work through that. Because if you have a lot of category mismaps or whatever it is you're doing, you need to have some way to build a feedback mechanism into the processing of the data. And then this is the cool part, is the overall classification accuracy is exceedingly good. I mean, you can see that, cresting at almost 99%, several days there, always pretty much way above 90% from an accuracy perspective. So, Comscore is in the press a lot today, these couple weeks, primarily because of all the e-commerce data. So I don't know if anybody saw it was Black Friday was the first $1 billion e-commerce day of the season, and then it was 1.47 billion in e-commerce on Monday. If you're ever interested in any little, factoid or whatever, there's a website out there called Comscore Data Mine. You can go ahead and go out there and use that all you want. And with that, I'm going to turn it over to Sharon and I for questions.